Welcome to lecture series on data structures. In today's lecture series, we will discuss about topic under multiple trees and graph called as minimum spanning tree. So before we go to look about the topic, let's have a quick recall on the previous topics we have discussed. So we have seen what is graph and what are the various terminologies in graph data structure. We have seen three ways of representing graphs such as adjacency matrix, adjacency list, and incidence matrix. We also have seen about the types of graph and graph traversal techniques, which includes breadth first traversal and depth first traversal. So here are the points that we are going to discuss today. So we will discuss about what is minimum spanning tree, and before that we will discuss about what is spanning tree, what are the various examples for spanning tree, and what are the various algorithms used for finding minimum spanning tree. And we will also get to discuss about what is the difference between a spanning tree and a minimum spanning tree and its application as well. So here is a real life application that will discuss about the need for minimum spanning tree in the best way possible. So we want to lay the telephone wires from a central office to all the other office premises. So first look at the first figure. uh, Telephone wires has been laid from the central office to all the other branch offices, and this establishment looks quite expensive. When you look at the second example, here the minimum total length or cost of the wire connecting all the customers or the office premises is minimized. So such kind of construction can be done, or it can be made possible with the help of minimum spanning tree. So this spanning tree, it is an approach which is especially used to reduce the cost. So here is a different strategies used for establishing the network, which we have discussed in the earlier slide. The first approach, which is a naive approach used for establishing the wire connection, looks pretty expensive. And second one is a better approach, which can be accomplished with the help of constructing a minimum spanning tree. So before we get to discuss what is minimum spanning tree, let us see what a spanning tree is all about. It is a connected and directed graph, and it can be considered as a subgraph of a given graph where all the vertices are connected together. So for a given a single connected graph, you can have many number of spanning trees. So the left side blue color figure shows the connected and directed graph, and right side shows the possible spanning trees for this particular connected graph. So the properties of spanning tree includes, uh, it says that there are several minimum spanning trees for say of the same weight. So every spanning tree of a given graph is of minimum weight. So for if consider if all the edges has unique weight or distinct weight, then for a given graph you will have only one minimum spanning tree. For a given graph, you can have more than one spanning tree, but if all the edge weights are distinct, you will have only one minimum spanning tree. So this minimum spanning tree does not contain any cycle, and it has n minus 1 edges, where n represents the number of vertices. Here are some of the applications where spanning tree concept is applied. It is used in identifying the maximum bottleneck path and removing it. It is used in error correction and image registration. It is also used for real-time face verification. It is used for reducing the data storage, uh, and it is also used for configuring the protocol for Ethernet bridging to avoid networks cycles. Here is a difference between spanning tree and minimum spanning tree. A spanning tree is a subgraph of a given graph which contain all the vertices of graph, and all the vertices are connected with minimum number of edges. So a spanning tree is a tree, can be considered as a graph as well as a tree. Minimum spanning tree of a graph, it's a spanning tree itself whose edge weight is minimum, whose total edge cost is minimum. So these are the two algorithms which are used for constructing minimum spanning tree. One is Prim's algorithm and the other one is Kruskal algorithm. So working of Prim's algorithm is almost similar to Dijkstra's algorithm, and Kruskal algorithm works by choosing the vertex with minimum cost that do not form a cycle. So we will discuss about these two algorithms in the upcoming lecture videos. Here is an assessment for you to recall. So which of the following is false in case of spanning tree? Uh, the fourth option, look at the fourth. So it is a tree that spans the graph. Yes, it is a tree that spans the graph. And it is a subgraph of the graph. Yes, it is a subgraph. And of course, spanning tree includes all the vertices of a given graph. However, it cannot be cyclic as well as acyclic. So by default, a spanning tree has to be an acyclic graph. So now second example is consider a complete graph with 4 vertices. The graph G has spanning trees. How many spanning trees can it have? It is n power n minus 2, which is 4 power 4. The formula to calculate the number of spanning trees for a given graph is n power n minus 2. Here n represent the number of vertices. So when you apply formula here, for n is 4. So 4 power 4 minus 2 is 4 square, which is 16. So for the given graph with 4 vertices, it can have 16 spanning trees. So what is minimum spanning tree? So minimum spanning tree is the one with minimum total cost. So for this particular graph, this is a minimum spanning tree. So we will discuss about the minimum spanning tree in the next lecture video. Hope you had a pretty good understanding of what is spanning tree and how to construct a spanning tree. So thanks for watching.